Okay, this next one's about x and y intercepts. And so x and y intercepts are the places where the graph is crossing the axes. So we kind of think of this as the graph, that would be the y-intercept, and down here would be the x-intercept. And so something about that is if you're looking for an x-intercept, the y is always going to be 0 because you're going to be neither above nor below the axis. Likewise, if you're looking for a y-intercept, then the x is going to be 0 because you're neither left nor right. So to find x and y intercepts, pretty much all you do is plug in 0 and solve for x, and then plug in 0 for x and solve for y. And that is intercepts. So let's see how that looks. With this, if I plug in the 0 here, oops, let me write that better, 3x minus 2 times 0 equals 6. So that whole chunk drops out, and I get 3x equals 6. So what I usually when I'm doing these is I just say, okay, if y is 0, I just kind of think of covering that piece right there up, and then I have 3x equals 6, and I can see pretty easily that x has got to be 2. And you get that writing it out also. But you can do a lot of these without having to actually do this step over here. So like here I'd go, so x is 0, so then that just leaves me the negative 2y equals 6, and then dividing that, y equals negative 3. So then that gets me my 2 points, and then I can use those to graph my line. So here when x is 2, y is 0, and when x is 0, y is negative 3. And so for the equations that are in this form, and what this is called standard form, and it's where it's like, well, the form looks like this, ax plus by equals c, but it's where the x's and the y's are on the same side. So when you're in standard form, the intercepts are pretty much really often going to be the easiest way to graph it, actually. So this is actually a pretty good technique for this style problem. So having said that, that means it's probably not the best technique for the next problem, which is the case. The y-intercept's great for this. If x is 0, that all drops out, and that number on the end there is always going to be the y-intercept. And as we get a little farther in the chapter, we'll see that this is y equals mx plus b, and that b is the y-intercept. So that's going to be negative 4. But so then finding the x-intercept on this one isn't as great. It's a little bit of work. So like I said, once we get some more techniques and we learn about slope, this is not how I'd graph this one. But for right now, if we're asked to find the intercepts, this is what we would do. Here I'm going to add my 4 over. And that's going to get me 4 equals 2/3 x. And then since I got a 2/3 there, I'm going to multiply both sides by 3/2. And that's going to go 12 over 2, so that would be 6 equals x. And then graphing, let's see, so y-intercept 0, negative 4, and x-intercept at 6. So it should kind of look like that. So this next one's a little bit special in that when I go to find the intercept, if I let, x equals 0, then y is 0. So you can see both intercepts are 0, 0. So I'm going to need to get one more point. Let me rewrite that down here since I just scribbled on it. 3x. So I'm going to need to get one more point in order to finish graphing my line. So then I can just kind of do the little t-table thing and say when x is 1, y would be negative 3, and then that gets me my second point. And my line would kind of look like that. So in a lecture class, the next, I think, 6 or so, for the rest of the video are all the ones I would have you guys try in class. It starts off with an exception, x equals negative 1, so we just looked at that. And remember, what this really means is it doesn't matter what y is, x stays negative 1, so y could be 0, y could be 1, y could be anything. And you can also just remember it's a vertical line. So if you remember it's a vertical line, cool, just draw it like that. But if you get mixed up and you're trying to like, oh, was it this one or this one? You can always make that little silly table and just do, negative 1, 0, negative 1, 1, and that'll help you get that orientated correctly. And so then the x-intercept has to be negative 1, right? Because that's all it does is it's there and it's negative 1. So the next one is its counterpart. So this is the y equals 4. So if you remember, that's a horizontal line through 4. Great. Go ahead and just draw that. And if not, if you get a little mixed up on which way does it go, make a little table, you know, because y's just got to be 4. And if you grab yourself a couple points, x is 0, y is 4, x is 1, y is 4, it'll help you get it going the right way. So, of course, no x-intercept for this, and the y-intercept will be 4. Next example, this one's in standard form again, so this is really not too bad. If I let y equals 0, you can see that whole y term is going to drop out, and I'm going to be left with, I'll go ahead and show it right here. You can see this just drops, and then you're just left with negative x equals 3, and carefully get that sign scooted over, and so that's going to make it x equals negative 3. And then if the y is 0, x is 0, then I'm left with 3y equals 3, and so then y equals 1. So you can see that's a pretty easy way to get that one graphed when the x and y are on the same side. So x is negative 3, y is 0, and when x is 0, y is 1. So it should be about like that. This is the other form, so this is slope-intercept form. So here when y is 0, we have to do a little math. And then I'll go ahead and solve for the x. So I'm scooting my 2 over. Negative 2 equals negative 3x. And then I can divide out the negative 3. Those cancel, and the negative from negative would make positive. And then the y-intercept, that's the easy one. When x is 0, y is 2. So that would be right here. And then 2/3 would be right about there. I don't think they're going to make you graph ones on the, in between the points like that, but there's one. This one, so this is that kind of game where we go, okay, we plug in the 0 for x, and we get, 0 for y. So we're just going to get 0, 0 twice. And then that's where it's beneficial to pick, that next point. So I'm going to pick, I could pick anything, right? I could pick 1, but then I'd have to graph a fraction. So I'm going to be smarter than the fraction, and I'm going to pick 3. Because then I have y equals 2/3 of 3. My 3's drop out. I get a nice, easy negative 2 to graph. So here we are at 0, 0, and then when x is 3, y is negative 2, and that gets us something about like that. And then these last couple, so let's see, if y is 0, let's see if we can do this without doing math. So if y is 0, that's gone. So negative 3 times something makes negative 12. So x would have to be 4. And if x is 0, this is gone. So 4 times something makes negative 12. So that would have to be a negative 3. So that's kind of the goal in terms of doing these intercepts with this. Makes it pretty easy. Let's see, so 4, 0, so x is 4, y is 0, and then 0, negative 3, we should be right there. And there's our graph. And then here's another one, not quite in the right form, so I'll do the easy one first. If x is 0, then boom, y is 2. That was nice. Here, if y is 0, then we got 0 equals 1/2 x plus 2. I'll scoop my 2 over, and negative 2 equals 1/2 x. And then we'll just multiply both sides by 2. And so then these guys cancel, and we got x equals negative 4. So let's see, negative 4, 0 right there, and x is 0, y is 2 right here. Cool. And that concludes intercepts.